Imagine a world where all your AI assistants, all those autonomous agents, could actually talk to each other seamlessly.
Yeah, like a real team effort.
Exactly. A synchronized digital orchestra.
Yeah.
Every instrument knows its part, maybe improvises a bit with the others.
Mm.
But right now, you know how it is. These LLM agents, they're powerful, sure, but they often operate totally alone.
Right, stuck in their own little boxes. Brilliant, maybe, but isolated.
Totally,
Yeah.
like brilliant minds stuck in different rooms. And that gap, that lack of communication, it creates this huge challenge, makes it really hard to scale things up, keep them secure, make them work generally.
Absolutely, it's a bottleneck.
So this deep dive, it's all about breaking down those barriers for you. Our mission today, give you a shortcut, really, to getting well-informed on the blueprints, the crucial blueprints, for building a truly interconnected AI ecosystem.
We're going to unpack 4 of the big ones.
Yeah, 4 cutting-edge communication protocols, MCP, ACP, A2A, and ANP. Each one designed specifically to let these digital brains, collaborate and share information.
And the core problem, fundamentally, is just that lack of robust, standardized ways for them to talk.
Yeah, current practices, they're just inconsistent, fragmented, make securing them, scaling up these multi-agent things incredibly tough.
It's holding things back.
So it really sounds like a communication breakdown is right at the heart of this. When we talk about these agents, what does interoperability actually mean here? And why is it such a huge hurdle?
That's a great place to start, interoperability, yeah.
Well,
In this context, it's simply the ability for different agents, different systems, to find each other, figure out what the other can do,
okay.
exchange information that makes sense in context,
Yeah.
and then coordinate actions
Yeah.
seamlessly, ideally.
Like different phone brands calling each other. Or apps sharing data.
Exactly like that. Think about how frustrating it would be if your Android couldn't call an iPhone,
Yeah.
right?
Impossible.
Without it, in the AI world, you get these isolated systems. Agents can't reuse cool functions other agents have built. And every time you want to connect 2 things, it's like starting from scratch. Huge development overhead. It's a real drag on progress.
Okay, let's unpack this then. We've got this big communication gap. But to really appreciate these new protocols, maybe we need to get specific about the obstacles. What exact problems are they trying to solve?
Right. The survey we looked at, it really highlights 4 critical challenges that these new protocols are designed to tackle head on.
Okay, 4 challenges. What's the first?
First, there's a lack of context standardization for LLMs. Imagine an LLM trying to use a tool like a search engine or a calculator.
Yeah.
But every single tool needs its instructions formatted slightly differently. The LLM needs specific structured data to give you good results.
Makes sense.
But if there's no unified way to deliver that context, you end up with these flaky ad hoc integrations. It's unreliable, like trying to plug in a USB stick, but every port is different.
Ah, yeah, the USB-C analogy from the intro. That clicks. Okay, so context for the LLM itself. What about agents talking to other agents?
Exactly. That's the second challenge. Communication barriers between heterogeneous agents,
Heterogeneous meaning.
meaning built differently. Maybe one's coded in Python, another in Rust. Maybe they're from totally different companies using different frameworks.
Gotcha.
Often they just can't communicate effectively. It's like they're speaking different dialects or even different languages entirely.
So they stay isolated.
Right. Leads to isolated behaviors, poor collaboration. You can't build those bigger cooperative systems if the parts can't talk.
Okay, that makes sense. What's number 3?
Third, even if they can technically send messages back and forth, there's still an absence of unified agent collaboration standards.
Meaning?
Meaning there's no shared rule book for how to work together on complex stuff. How do they dynamically negotiate who does what? How do they securely share their capabilities? How do they coordinate a task that takes multiple steps involving multiple agents?
Ah, okay. So it's not just about basic communication, it's about the rules of collaboration.
Precisely. It's like having a team of brilliant engineers who can all talk, but nobody's agreed on the blueprints or the project plan.
Right, chaos.
Yeah.
Okay, and the last one. You mentioned this internet agnostic challenge.
Yes. Number 4, internet agnostic agent communication, the current internet. It's amazing for us, for humans, browsing websites, sending emails.
Right.
But it wasn't really built with autonomous agents in mind. They need things like super low latency, ways to talk directly via APIs almost natively, and really strong, secure, maybe even decentralized ways to prove who they are.
Okay, so the current internet infrastructure isn't quite right for them.
Not optimally, no.
Yeah.
Especially not for large-scale, secure, open interactions between agents from across the whole internet. We need sort of a shift in how the net supports machine-to-machine interaction.
Wow, okay. Those are some significant hurdles. Now, this whole idea, agents talking, doesn't feel completely brand new, does it? I feel like I've heard about this concept for a while. What's the history here?
You're absolutely right. It's not new at all. The quest for agent communication standards actually has a pretty fascinating history. You can sort of break it down into three phases.
Okay. Lay it on us.
So the first phase, let's call it symbolic and SOA foundations. This was roughly, say, 1993 up to around 2006.
Okay, early days.
Yeah. Early efforts like KQML, that's Knowledge Query and Manipulation Language from 93. It introduced these things called speech act primitives.
Speech acts, like ask or tell.
Exactly like that. Yeah. Basic communicative actions for knowledge-based agents. Then came FIPA ACL Foundation for Intelligent Physical Agents, Agent Communication Language. That was standardized around 2000.
And what did FIPA ACL do?
It really refined things. It added formal semantics, a much more precise way for agents to understand the meaning behind the messages, not just the words, like developing a perfectly clear grammar for AIs. And then later in that phase, you had web services, things like SOP and WSDL around 2002, and then Enterprise Service Bus, ESB patterns around 2006. These were more focused on trying to streamline how big companies integrated all their different software systems.
Well, I remember SOAP often felt heavy.
Exactly. That's kind of the lesson from that era. These early attempts, while groundbreaking, they often ended up being quite complex, heavy-handed, difficult to actually implement widely.
So complexity was the enemy of adoption.
Pretty much. It showed we needed something much more lightweight, more standardized, if agents were ever going to really chat efficiently at scale.
Okay, that makes perfect sense. Simplicity wins. So what was the next phase after that?
Phase 2, we could call retrieval and in-model action. This is more recent, maybe 2020 to 2023.
Okay.
Here we saw big leaps like RAG retrieval augmented generation in 2020. That was about pulling external knowledge into the LLM's brain as it generated text, made them smarter, more grounded.
All right, LAG is huge now.
And then a real game changer was OpenAI's function calling in 2023.
Yes, function calling. Big deal.
Huge deal. It let the LLM itself directly output structured JSON instructions for calling external tools or APIs.
So the LLM could actually do things.
Exactly. It wasn't just generating text. It could trigger actions. And other things like Toolformer, React, they further push this idea of LLMs learning to use tools and mixing reasoning with actions.
Okay, so here's where it gets really interesting, I think. We had the early, maybe complex standards. Then LLMs got good at using tools directly. So what makes this current phase protocol-oriented interoperability? What makes it different? Why are these 4 new protocols we're focusing on today so important now?
Great question. This current phase, kicking off around 2024, it directly tackles the limitations we just talked about. It learns from the past. The focus now is on lightweight, standardized protocol.
Okay.
Protocols specifically designed for dynamic discovery, how agents find each other secure communication, and truly decentralized collaboration. It's moving beyond just one LLM calling one tool.
It's about the whole ecosystem.
Exactly. It's about building interconnected ecosystems of agents. These 4 protocols are laying the groundwork for much greater scalability, much more robust interoperability than we've ever really had the tools for before.
All right, let's dive into them then. Let's start with MCP. What exactly is the Model Context Protocol?
Right, MCP, Model Context Protocol. Think of this one as being all about standardizing how applications feed information to the LLM.
Feeding information, like tools and data.
Precisely. Tools, data sets, instructions. The paper calls it akin to a USB-C for AI. And I think that's a pretty good way to think about it. A universal plug.
Okay, USB-C for AI. I like that. How does it work technically?
It uses a JSON RPC client-server interface.
JSON RPC, can you break that down simply?
Sure. JSON RPC is just a very standard, structured way for computer programs to send messages back and forth, like a really clear instruction manual for requests and responses. It ensures things are predictable, which is crucial if you want an LLM to reliably use an external tool.
Got it. Predictable instructions. And what can MCP actually do? What are its capabilities?
It has 4 main capabilities. First, tools. These are functions controlled by the model, the LLM. Allows the LLM to call external APIs, do a search, send a message, update a database, whatever.
Okay, tools.
Second, resources. These are controlled by the application providing the context. Think structured documents, data sets, things that give the LLM specific tailored information for the task at hand.
Context, okay.
Third, prompts. These are controlled by the user, often reusable templates to ensure you interact with the LLM consistently for certain tasks.
Right, reusable prompts.
And fourth, something called sampling. This one's interesting. It's server-controlled. It actually lets the MCP server delegate the generation of the LLM's response back to the client.
Wait, the client generates the LLM's text. Why?
It allows for really fine-grained oversight. The client can control exactly how the text is generated, apply specific constraints, monitor it closely, useful in high-stakes scenarios.
Okay. Oversight. That leads nicely into security. Beyond the clever tech, what are the big security worries with MCP? What keeps people up at night, and what are the fixes?
Yeah, security is always paramount. With MCP, you worry about things like tool poisoning.
Tool poisoning. Sounds nasty.
It is. It's where someone crafts malicious prompts or inputs, hoping to influence the LLM's behavior when it uses a tool, maybe make it leak data or perform unauthorized actions.
Oof.
There's also classic command injection, trying to sneak unsafe inputs past the LLM that then get executed by the underlying system the tool connects to.
Nasty. So how do you defend against that?
Multiple layers. Rigorous validation of the data structures, the schemas, strong input sanitization, cleaning up any potentially harmful characters or code, and using things like digitally signed, versioned manifests for the tools.
Manifest.
Like a list of ingredients for the tool, proving it's the official version and hasn't been tampered with. It's about building in checks and verification at every step.
Okay, robust checks. So MCP gets the right context and tools to the LLM. But what about when you have, say, two totally different AI systems, maybe from different vendors, needing to communicate with each other? That seems like a whole different ball game. Is that where ACP comes in?
Exactly. That's the perfect transition. That's where the Agent Communication Protocol, or ACP, steps up.
Okay.
ACP is specifically designed to bridge those communication barriers between different kinds of agents built on totally different frameworks.
Making different systems talk.
Right. It uses a REST native approach.
REST native, meaning it uses common web standards.
Yeah, it fits well with existing web infrastructure, makes it easier to adopt. It's also SDK optional, so you don't have to use a specific library. And it has open governance under the Linux Foundation, which helps with standardization and trust.
Open governance is good. How does it work? Who are the players?
It operates with three main roles.
Yeah.
You have the agent client. That's the agent starting the conversation, finding other agents, putting together the request.
Okay, the initiator.
Then there's the ACP server. This acts like a protocol broker or a switchboard. It keeps an agent registry, basically a phone book for agents.
A phone book for AIs. I like it.
Yeah. And the server enforces rules, like authentication, and routes the messages to the right place.
The middleman.
And finally, the ACP agent. That's the endpoint. The agent that actually does the work, processes the request, and sends back the results, often as things called artifacts.
Artifacts being the output.
The tangible output, yeah. A key strength of ACP is its support for multimodal messaging.
Multimodal, meaning more than just text.
Exactly. Images, audio, video,
Oh.
richer conversations, and also asynchronous streaming, which means agents can have ongoing dialogues, not just simple back and forth requests.
Okay, richer, ongoing chats. Now security again. Messages flying around via this broker. What are the main ways this could go wrong? What are the big attack vectors for ACP, and how do you safeguard it?
Good question. With ACP, you worry about message tampering, someone changing the message content while it's in transit, or man-in-the-middle attack, someone secretly intercepting and maybe relaying messages.
Listening in or messing with the conversation.
Right. And of course, authentication flaws, someone figuring out how to impersonate a legitimate agent or gain unauthorized access.
Standard web security concerns, basically.
Pretty much would apply to agents.
Yeah.
The mitigations are also fairly standard, but crucial. Using TLS for transport security, that's the S in HTTPS, encrypting the connection.
Okay, basic encryption.
But also, crucially, signing each individual part of a message using JSON web signatures, JWS.
JWS, what's that?
Think of it like a digital wax seal on every piece of the message. It proves who sent it and that it hasn't been tampered with since it was sent. Very important.
A digital seal, got it.
And finally, using capability-scoped, short-lived access tokens. So any access granted is very specific to a task and only lasts for a short time. Limits the window for abuse.
Makes sense. Limit the blast radius. Okay, so MCP for LLM context, ACP for getting different systems talking. What about structured collaboration, maybe delegating tasks, but specifically within an organization like an enterprise? That feels like it might need its own approach. Tell us about A2A.
Spot on. That's exactly the niche for the agent-to-agent protocol, or A2A. It's designed for peer-to-peer task outsourcing, primarily within a trusted environment like a company.
Peer-to-peer within the company walls.
Right. It aims to simplify those complex enterprise-scale workflows where you might have multiple specialized agents needing to work together. It enables that dynamic interaction even if the agents use different tech stacks internally.
Okay, so how does A2A structure this internal collaboration? Who's involved?
It defines three main actors. First, the user. This is who originates the task. Could be a person, could be another automated system, could even be another agent kicking off a subtask.
The task originator.
You have the client agent. This agent acts on behalf of the user. Its job is to figure out the user's intent, find the right other agent to do the job, the remote agent, using something called an agent card.
Agent card. We'll come back to that. So the client agent finds the right helper.
Finds the helper, initiates the task, manages the back and forth of messages and those artifacts, the results.
Then the third actor?
The remote agent. This is the agent that actually does the work. It acts as the service endpoint, offers specific skills, and it publishes its agent card so others can find it and know what it can do.
Okay, let's talk about the agent card. You said the client agent uses it for discovery. It sounds important. What exactly is it?
It's absolutely crucial for A2A. Think of agent card as like an agent's digital business card plus its resume, all rolled into one, formatted as JSON.
Okay, a structured description.
Exactly. It describes the agent, lists its skills, what it can do, and tells other agents how to interact with it. It's the key mechanism for discovery and figuring out capabilities within that trusted enterprise environment.
Makes discovery easy. And you mentioned tasks and artifacts again.
Right. In A2A, tasks are the sort of basic units of work being delegated, defined by the protocol. And artifacts are the tangible results that come back from performing a skill, like a generated report, processed data, that kind of thing.
Got it. Now, since this is geared towards enterprise, security must be absolutely top of mind. What are the specific threats here inside the organization, and how does A2A lock things down?
Even within an enterprise, you can't assume perfect trust. Significant threats for A2A include things like agent card and manifest spoofing.
So faking an agent's identity.
Exactly. A malicious actor, maybe an insider or compromised system, trying to impersonate a trusted agent to intercept tasks or gain access it shouldn't have.
Okay, impersonation. What else?
Task injection and command forgery. This is about maliciously manipulating those task requests, the JSON RPC calls, maybe to make the remote agent do something harmful or unintended.
Tricking the agent into doing bad things. How do you stop that?
A2A proposes pretty strong mitigations. Digitally signing the agent cards is key, proving they're authentic.
Like signing the manifests in MCT.
Very similar principle. Verifying checksums when you download an agent card to make sure it wasn't altered.
Yeah.
And again, using those JSON web signatures, JWS, but this time to sign the actual task payloads, ensuring the request itself is intact and came from the claimed client agent.
Lots of digital signatures keeping things secure. Okay, so MCP for the LLM interface, ACP for general agent chat, A2A for trusted enterprise collaboration. We've covered a lot of ground. But what about going really big? Beyond the company walls, out into the wild west of the open internet, having agents find and work with potentially any other agent out there.
The final frontier.
Yeah, that seems like a massive leap. My first thought is, how on earth do you handle identity and trust in that kind of open, decentralized free-for-all? That internet agnostic challenge we mentioned earlier feels absolutely critical here. How does ANP tackle that?
You've hit the nail on the head. That's precisely the challenge the Agent Network Protocol, or ANP, is designed for.
Okay, ANP for the open internet.
Exactly. It's envisioned as a decentralized peer-to-peer standard specifically for cross-platform agent interoperability across the public internet. Built for discovery, authentication, interaction, using structured metadata, all in that wide open environment.
Decentralized peer-to-peer sounds ambitious. How does it solve that massive identity and trust problem you just mentioned?
That's where decentralized identifiers, or DDAs, become absolutely central.
DADs, okay, I've heard of those. How do they work here?
ANP specifically talks about using the did.wba method. The key idea is that each agent's unique identity, its DID, is tied to a publicly resolvable HTTPS web address.
So you use the existing web infrastructure.
Exactly. It leverages the web's domain name system, DNS, and secure connections, HTTPS, to provide a basis for verifiable, immutable identity. You can look up an agent's DID document at its known web address.
Clever. So what are the key pieces of ANP that make this work?
There are a few core components. First, obviously, agent identity using these DIDs. That's the foundation.
Got it. unique ID tied to a web address.
Second, the Agent Description Protocol, or ADP. This uses JSON-LD, that's JSON, for linked data to create structured documents describing the agent, its capabilities, its services, how to talk to it.
Like A2A's agent card, but maybe more standardized for the open web. Sort of, yeah, but using linked data principles. And these ADP documents are published at a standardized web location for that agent, usually under well-known agent descriptions. Makes them discoverable via standard web means.
Okay, discoverable descriptions. What else?
Perhaps the most futuristic part is the Meta-Protocol Negotiator.
Meta-Protocol Negotiator, what does that do?
This is really cool. It allows two agents, when they first connect, to dynamically negotiate and agree on which communication protocol they're going to use for their actual conversation.
Wait, they decide how to talk after they connect?
Yes, based on maybe natural language descriptions of the protocol they both support. It's like two people meeting and one asks, hey, do you speak English or Spanish? And they agree on a language before getting down to business.
Wow. Okay, that's incredibly flexible. It's like an AI handshake about the rules of engagement itself.
Exactly. It avoids locking everyone into one single protocol for all time. Vital for a diverse, evolving open network. Mind blown a little. Okay, security. Open internet. Decentralized identity. The attack surface feels huge. What are the primary security challenges for ANP out there in the wild?
You're right, the threats are significant. Critical ones include identity spoofing, trying to create fake DID documents, or somehow hijack a legitimate agent's DID.
Impersonation again, but maybe harder to trace.
Potentially, and also unverified agents. Agents trying to interact without proper DID authentication, maybe bypassing checks to cause trouble anonymously.
Sneaking in under the radar, how do you mitigate that in such an open system?
The proposed mitigations lean heavily on verifying those DIDs. Enforcing the DIDs must be hosted via HTTPS. Verifying the DID's link to a domain using DNS records, proving the agent actually controls the claimed web address. And requiring cryptographic signature validation using the keys listed in the DID document for any real authentication or sensitive interaction.
So, leveraging web security standards and cryptography heavily.
Absolutely. It's about building trust anchors even in a decentralized world.
Okay, wow. MCP, ACP, A2A, ANP. 4 distinct protocols, each tackling a different layer or context of agent communication. So what does this all mean for us? How do they actually compare? Is one better? It feels like the key insight isn't about picking a single winner, is it?
Definitely not. That's maybe the most important takeaway here. No single protocol is the magic bullet for every problem. They're designed for different jobs, different tiers of interoperability, different places you might deploy agents.
Right, like you said, different roads for the AI city.
Exactly. Think about their architecture. MCP is classic client-server. ACP is also client-server, but with that broker in the middle. A2A is more peer-like, client talking directly to a remote agent. And ANP is fully decentralized peer-to-peer.
Different structures. What about finding other agents? Discovery.
That varies too. MCP might be manual or static configuration. ACP uses that central agent registry. A2A uses those agent cards discovered via HTTP within the enterprise. And ANP aims for much broader discovery, maybe even using search engines eventually, based on those ADP descriptions.
And identity and authentication? Sounds like that ramped up too.
It did, from fairly simple token-based access in MCP, potentially, up through mutual TLS and those JWS signatures in ACP, to DID-based handshakes, potentially in A2A, and then fully decentralized DIDs with cryptographic verification in ANP. It gets progressively more robust for more open environments.
And their main use cases seem pretty distinct, too.
Very distinct. MCP, strictly LLM tool integration. ACP, more general, model-agnostic agent messaging, maybe at the infrastructure level. A2A, trusted enterprise collaboration, internal workflows. ANP, open internet, cross-platform agent markets, truly decentralized stuff.
And I guess each one comes with its own trade-offs.
Comes trade-offs. For example, MCP gives you that really tight, efficient LLM integration. Huge plus. But it often assumes a central server managing context, and you still have risks like that tool poisoning we talked about. ANP, on the other end, offers incredible potential with trustless identity and that amazing meta-protocol negotiation. Groundbreaking for the open internet. But it definitely involves more complexity, more overhead in negotiation, and it relies on a whole ecosystem adopting DIDs and related standards.
So each is optimized for its niche.
Exactly. You pick the right tool or the right protocol for the specific job you need done in your agent ecosystem.
Okay, this is incredibly rich information, and I'm sure for you listening, it might feel like Well, a lot to digest all at once. Four protocols, different architectures, security models. Is there uh, like a recommended path, a way for organizations to start adopting these ideas without getting totally overwhelmed, a sensible way forward?
Absolutely. And the survey actually proposes a very clear, phased adoption roadmap. It's designed to guide organizations through this, building capabilities progressively.
Oh, that's helpful. A roadmap. What does it look like?
It's a four-stage process, starting simple and getting more sophisticated. Stage one is MCP for tool invocation.
Start with the basics. Getting the LLM to use tools reliably.
Exactly. Use MCP to get that secure, structured interaction between your LLMs and your existing tools or APIs. It's a fantastic, relatively low-risk starting point. Get deterministic execution working first.
Makes sense. Stage one, solid tool use. What's next?
Stage two is ACP for rich interaction. Once you've got tools working via MCP, you layer in ACP. This brings in that asynchronous multimodal REST native messaging. It lets your agents have richer conversations, especially useful for connecting different internal systems that might be built differently.
Okay, stage two, richer internal chat between systems then.
Stage three is A2A for enterprise collaboration. If you have more complex internal workflows where multiple agents need to collaborate and delegate tasks within the company, you adopt A2A. Leverage those agent cards, structured skills, artifact exchanges, all within your trusted organizational boundary.
Stage three, sophisticated internal teamwork. And the final stage.
Stage four is ANP for open agent markets. This is the big leap. Extending interoperability out onto the open internet using ANP. This means embracing decentralized discovery, DID-based identity, potentially participating in or building cross-platform agent marketplaces.
Stage four, going global and decentralized.
That's the progression. Start internal and foundational, then enable richer internal interaction, then structure complex internal collaboration, and finally, connect to the wider world.
That phased approach does sound very sensible. Logical steps, start simple, build complexity. It respects your time and gives you a clear path to building these increasingly sophisticated agent ecosystems. But I have to ask, are there any hidden traps or downsides to this nice, neat progression? Could a company get stuck? Or maybe miss out by being too linear?
This is a really insightful question. While the roadmap is logical, yeah, there are potential challenges. Moving towards stage four, towards ANP, requires not just tech changes, but potentially a big shift in organizational culture to embrace decentralization. That can be hard.
Culture change is always hard.
Definitely. Or, conversely, if a company is too cautious, stays in the earlier stages too long, they might miss out on early mover advantages if open agent marketplaces built on ANP really take off.
Right, the risk of being left behind.
So it's not just about blindly following the stages. It requires continuously assessing your own needs, your capabilities, and what's happening in the broader ecosystem. It's a strategic roadmap as much as a technical one.
Fascinating. Strategic and technical. Well, we have certainly journeyed through a lot today. The critical need for agents to talk, for interoperability, and we explored these four powerful potential solutions. MCP for that direct LLM tool link, ACP for robust multimodal messaging between systems, A2A for sophisticated collaboration inside an enterprise, and ANP for weaving decentralized agent networks across the open internet.
Yeah, quite a tour.
And it's crucial to remember these aren't just, abstract tech specs. They're potentially the fundamental building blocks. They're what could transform this currently fragmented AI landscape into something robust, secure, truly interconnected ecosystems where AI can work seamlessly for you across all sorts of different systems and environments.
That's the vision, yeah.
So let's end with a provocative thought for you to chew on. If these protocols, or ones like them, truly manage to create this unified nervous system for AI, where agents can discover, trust, and collaborate with each other almost instantly on demand, what entirely new kinds of complex collaborative tasks could they tackle? Things that are just impossible today. Imagine the possibilities. What if every specialized AI agent, a legal research bot, a drug discovery simulator, a logistics optimizer, a climate modeler, could instantly find and securely work with any other specialized agent to solve a problem that's way beyond human scale right now? What societal shifts might that kind of AI cooperation bring? What huge problems, things we think are maybe unsolvable today, might suddenly become, well, maybe not trivial, but solvable when AI can truly team up at this level? Something to think about.